So we have already done the geometrical meaning of conics. So why it is called conic section? Because it is a section of a plane and a double cone. Now today we'll see the locus of a conic section. Locus of conic section. So what is locus? What is locus? If some point is moving at some condition, we say this is the locus. Locus is a path of point. So it's something in a layman can say a path of points on which they are moving. Okay, but it can't be any random. It can't be any random path of a point. It should be defined by some constraint. Okay, that means locus is something set of points satisfying a given condition. Satisfying a given condition. So this is the definition of a locus. So it can't be any set of points. It should be defined by some condition. It should satisfy some condition. Then we'll see that we will say that the locus of particular points. Okay, so they are just a points, but it's not a random point. It should be satisfying some condition. For example, if you know the circle, so suppose the point is a fixed point. Okay, the fixed point is not the locus. This is a fixed point, and a point is moving such that its distance from a fixed point is always fixed. So this point is moving. Okay, this point is moving like this. This is moving. The point is moving such that its distance from a fixed point is constant, that is r. So distance from a fixed point is constant. That the path this is being followed, that is basically locus. Okay, this is locus. So locus has two things. First, it has equation, and second, it has some geometry. So what is the locus in this condition where the point is moving such that distance from a fixed point is constant, is a circle, and it has some equation. So first of all, we should know that the geometry of this locus is a circle. So in case of circle, a point is moving such that its distance from fixed points is always constant, that is r, that is constant. Same way, if we talk about the locus of a conic section, so in case of a conic section, so locus of conic section. So obviously it must be satisfying some condition, just like in case of a circle, it was satisfying a two conditions. First, the point was moving such that distance from a fixed point was constant. So one was point, other was a distance. So this distance was fixed and the point was fixed. So the point on a circle was moving such that distance from a fixed point was constant. So same way, locus of conic section is also defined with respect to some condition. So here locus of conic section is defined using the fixed point and fixed line. In case of a conic section, this fixed point has special name. Fixed point is called the focus, and the fixed line is called the directrix. So what is the locus of conic section? If we define locus of conic section, we can say that it's a locus of set of points. Locus of point P. Locus of point P which moves obviously in a plane such that, so some condition is there, such that, what is the condition? Such that the ratio of its distance from fixed point to its perpendicular distance from fixed line is constant. Okay, so suppose this is a fixed point, this is fixed point, I say it's a f, and let's say its fixed line is this. Okay, so there is some variable point p. So the point p is moving such that its distance from a fixed point, let's say this distance from a fixed point is, let's say, d1, and to its perpendicular distance from a fixed line. So let's say perpendicular distance from a line is d2. So the point p is moving such that this distance d1 upon d2 is equal to constant. Then the p will trace a conic section. So obviously p is a variable point. It's a variable, it is moving, it is tracing variable point which will trace the conic section. F is a fixed point, that is called focus. It is called focus. So fixed point means they are not moving, and this is a fixed line, they are called the directrix. So obviously fixed line means line is fixed, point is fixed, but this point p is moving, that will trace a conic section. So p is the locus by p. So p is following some, p is the path of a point, that path of points will trace a locus, and that locus is some conic section. Okay, so it may trace any curve, let's say it may be tracing something parabola, let's say. Okay, so the p traces a conic section. So fixed line, again this fixed line is called, just like in case of a circle, if you recall, in case of circle this fixed point is called the center of a circle, and the fixed distance is called radius of circle. Same way here, this fixed point is called the focus, and the fixed line is called the directrix. So they have some nomenclature. So a conic section will be traced if a p is moving such that its distance from a focus and distance from a directrix is constant. So I can say that p f upon p, let's say m, pf upon pm is constant, and then constant is called the E, eccentricity. E, that is we'll see in detail what is eccentricity, but let's say eccentricity. Okay, so this is obviously this is one more thing, this is called eccentricity if it is pf upon pm. So distance from a focus, distance from focus upon distance from line, directrix. Distance from directrix is equal to constant. The ratio is constant. Okay. Now we already discussed previous that there is a degenerate case and the non-degenerate case. So we have to see what is the condition, because obviously they behave something different, the conditions are different. So based on the position of a focus and directrix, we have non-degenerate and degenerate case. So let's say degenerate case. So degenerate conic section. So degenerate conic section is obtained if the focus lies on directrix. So it may happen that, so this is the directrix and this is the focus, but if the focus will lie on the directrix, that is the condition that this is the directrix and somewhere is the focus. This is the focus and this is the directrix, fixed line directrix. In this case we will get a degenerate conic section, whereas non-degenerate conic section is obtained if the focus do not lies on circle. So if focus do not lie on directrix. So that is if this is the directrix and this is the focus which do not, if the focus do not lie in directrix, then we get a non-degenerate conic section. Let's talk about eccentricity. Eccentricity of conic section, that is E, is we already discussed. The distance is focus, this is directrix, so this is distance, this, let's say M is a point on a directrix, so the E is the PF upon PM. So this eccentricity, so E is the distance of a moving point P from fixed point, if I say fixed point, that means it's a focus, upon distance of moving point P from fixed line, that is directrix. So E, again I am emphasizing, E is defined if distance from variable point from focus upon distance of variable point from the directrix, that is E. So E is not, so you can't be reverse, don't make it reverse. This is not the PF, this is not the thing. Even though if the distance from focus to and distance, the variable point P has a distance from focus and distance from a directrix is constant, they will trace a conic section. That means even if I say PF upon PM is equal to constant, it can be anything. So PF upon PM is equal to constant, that will also trace a conic section. Or if I say PM upon PF, that is constant, that is also trace a conic section, because the ratio is constant. Important is ratio. But the thing is, the eccentricity, there is something called eccentricity, we will see that the eccentricity is defined only for PF upon PM. Okay, this is the case for eccentricity. And we will see this eccentricity is 0 for a circle, it is 1 for a parabola, less than 1 and greater than 0 for a ellipse, and eccentricity is greater than 1, then it will trace a hyperbola,